Okay, starting this week, I'm going to be using this opportunity to go through some of your exit projects and your research papers. We usually do this around this time of year, having students get up in front of the room, give them about 3 minutes to present, and then students have the opportunity to question or comment regarding the project. But since we're not in school, I am going to present the projects, which reminds me, if you have put a voiceover on here, it would make it kind of nice because we would be able to watch that then. But these two projects do not have voiceovers, and they're both exit projects of sixth graders. And if you've read this Google assignment, I would like you to put down in a notebook the name of the exit project or the research paper. Today it's going to be two exit projects. First name of the students. What's your first impression of the project? Whether you're looking at the name or you're looking at the idea or the graphics, whatever your first impression is about it. What do you like or dislike most about the project? Please be respectful. We try and be as respectful as possible. And what would you have liked to have seen changed to make it a better project? So let's see if I can do this by, I can, good. I can change the size of the screen that you're looking at, or can I? Or can I? Apparently not. Okay, so we're stuck here. Okay, so our first project is going to be wind speed. This is by Maxim, Landon, and Daniil, and they are in class 631, my favorite class. Is it really? I don't know. Okay, so let's take a look through it. Problem. Does wind speed affect the amount of pigeons observed at a park? Hypothesis: if pigeons, are observed at a park during times of different wind speeds, none, mild, medium, or high, that are measured by an anemometer in knots, then more pigeons will be observed during times of low wind speed rather than high wind speed because during high wind speeds birds aren't able to fly, which means birds tend to take cover behind natural resources. Okay? On to our IDD. Independent variable, amount of weeks. Dependent variable is going to be wind speed recorded by an anemometer and the amount of pigeons observed. Constant, this is going to be the time during each day per week and location. Everybody understand? So far, so good. And we can see by the IDD here, they have the independent variable up here. They have the number of trials down here. And this is going to be the change in the IV. Okay? So let's go on to our next one. Nice graphic of an anemometer. And what else is there? What is that object that is pointing north by northwest? Well, we'll come back to that. Okay, so the materials: anemometer, notebook, pen, and pencil. Probably a couple of birds in there too. Okay, so the procedure will be go to the same location at the same time every day for 8 weeks, record the wind speed in knots, count amount of pigeons, record data, repeat steps 2 to 4 every day for 55 more days. Average the amount of wind speed and pigeons. Okay, so let's see. This is their data table. Their wind speed looks to be anywhere from 4.5 knots, probably down to, the high is over here is 5. So they're looking at anywhere from 1 to 1.7 to about 5 knots. A knot is it's a nautical miles per hour. Usually it's measuring currents. So wind and water would be measured in knots, where if you're driving a car, miles are kilometers per hour. Okay, pigeons, and we have our number of pigeons here. Okay, so let's take a look. From this data table, they have extrapolated a graph which we're looking at the amount of pigeons for our darker blue lines, and the light blue line is going to be our wind speed. So apparently it looks as though as the amount of pigeons is higher, the wind speed is lower. So we'll take this point right here. If we are looking at the amount of pigeons being 6, then our wind speed would be almost down to nothing. And here, if our number of pigeons would be 7, wind speed would be at about 1 knot. But if we have higher wind speed, you're going to see lower pigeons. Pretty straightforward and neat graph to look at. So the conclusion, our data did support our hypothesis because more birds were seen during low wind speeds. For example, week 1 had 2 birds seen with a wind speed of 4.5 knots. In week 2, 7 birds were seen with a wind speed of 2.3 knots. So the example data shows that our hypothesis is correct. I see there is no reference at the end. So this is the end of the presentation. I am going to quickly go through it, just give a couple of my initial impressions right off the bat. Number 1, I really like the appearance. As you go through the slides, you see the background's nice and changed. There's pictures of pigeons. I like that. I also like that they've used an appropriate font size when they're doing this, because this should be larger, names should be smaller. I like it. It's well spaced out. Everything looks good. When you get to here, everything looks good as well. My question comes from, are we just observing pigeons at rest? Are they flying? Are we counting them flying at all? I'm not really too clear on that, but if we're just looking for pigeons in the park, I would like that to be maybe a little more classified. Independent variable. What should the independent variable be? I want you to give some thought to this. What is your dependent variable? So I want you to look at this table, and I want you to give some thought to your IV and your DV, and maybe a little bit to the constant as well. Okay, what's this right here? It's a wind vane. This is something that tells you the direction the wind is blowing from. It always points, the smaller end is always going to point where the wind is coming from, the direction of the wind speed. So it's coming from our north by northwest here. And so your tail is always going to be going away from the wind. And let's see, 55 days they recorded this. Okay. Come down onto our graph. We'll look over this again, nicely put together. When you have something like this is a very small thing I'm picking on, but when you have something like this, you could have spread that out a little more. Okay, well, let's go on to our next presentation, which is going to be, let me see if I could change this right here. I don't think I can, though. No, I can't. Okay. Anyway, this is from Lexia and Erica in 632. And so they're doing the effect of time on vehicles. How does time affect vehicles? Let's take a look through here. Question is, how will the time of day affect the number of vehicles seen at a particular location? Hypothesis: if the number of vehicles seen on Shore Parkway is counted every day at 5 different times, 3 a.m., 7 a.m., 2 p.m., 5 p.m., and 8 p.m. for 1 minute over each, 1 minute each over a period of 30 days, then the most vehicles will be seen at 7 a.m. because it's the time closest to rush hour. Background information: traffic is typically worse in the evenings. Hour with least traffic is 4 a.m. on weekdays and 10 a.m. on weekends. There are usually more cars seen on Friday than any other day of the week. There are usually less cars seen on Sunday. Rush hour is usually from 8 to 10 a.m. in New York. They're going to give their literature cited here. And the IDD, independent variable is going to be the time of day. Your dependent variable is going to be the number of the vehicles seen. Constants, location, number of lanes counted. You can see the rest of the constants there. I'd like to get through this a little bit quicker than the other one because you'll usually have about 3 minutes. Okay, materials, resources, one-timer, vehicles, and road, and a couple of students from 632. Procedure, at 3 a.m. on Shore Parkway, set a timer for 1 minute and count all the vehicles on the road until 1 minute passes. Record the data. Number 2, repeat step 1 at 7 a.m. Step 3, repeat step 1 at 2 p.m. In step 4, repeat step 1 at 5 p.m. 5, repeat step 1 at 8 p.m. instead of 3. Okay, so this is their data for a total of how many days? 30 days, counting the vehicles at 3 a.m. This is for 7 a.m., and again, this is going to be for a total of 30 days over here. Again, 30 days again, and they're counting the vehicles. This is 2 in the afternoon. This is going to be at 5 p.m., and then again at 8 p.m. And a lot of data here. Okay, and they've put this into a, I hate getting those messages, into a data table where they have their independent variables and their dependent variables. Title, this is their graph. Their graph is going from 3 a.m. to 8 a.m., to 8 p.m., and we go all the way from 0 cars up to a possibility of 175 up there. They maxed out at about a little over 140. Title, time of day versus the number of vehicles seen. X-axis, the time of day, and the Y-axis, number of vehicles. Data analysis, the data shows that most cars were seen at 2 p.m. At 2 p.m., there was an average of 141. This means there were 116 more cars at 2 p.m. than at 3 a.m., 98 more cars than at 7 a.m., 30 more cars than at 5 p.m., and 15 more than at 8 p.m. Interesting. Okay, in our conclusion, our hypothesis was not supported by the data. As stated in the hypothesis, the most vehicles will be seen at 7 a.m. because it is closest to rush hour in New York. According to the data, the most cars were seen at 2 p.m. If the times when we were collecting the data in order to put are put in order from least amount of cars to the greatest amount, the order will go 3, 7, 5, 8, and 2. It is likely that the average number of vehicles seen at 2 p.m. is higher than at any other times. And I'm going to skip through a little bit, reflecting upon the data and the current situation with the virus. The data may be affected by the COVID-19 and quarantine. For further investigations, it may be better to collect data without a serious pandemic going on. How true that is, if possible, although it is extremely hard to predict when one will happen, and that is also true. Okay, so let's go back up through here. And again, you should be making little notes on either one or the other of these. I'm going to have you put them in there. Let's take a look. I will say it's the same background on all the slides. Could have had a few cars in the picture there. That would have been nice. If the vehicles, this is just me looking at this, if we're talking about closest to rush hour is 7 a.m., this is just my opinion, I would have made it at 6 in the morning, 6:30, 7, 7:30, and 8 would have been a better way to reference exactly whether that's going to be 7 a.m. because these other numbers are way out there. Also, I see you have 3 a.m. here, and you have 4 a.m. I'm sure it's just a typo, but I think most of your notes were for 3 a.m., if I'm not mistaken. And I give you girls credit for waking up at 3 a.m. Okay, so I want you to look through the rest of this. You can replay the video again and add in your Jupyter discussion exactly what you think about the projects. And I hope you enjoyed this.